Hello student, now today we will discuss the topic numerical solution of equations. Now in numerical analysis there are so many numerical methods are available to find solution of algebraic as well as transcendental equation. Now in scientific and engineering field the main problem arises to find the root of the equation f of x is equal to 0. Many problems in engineering as well as scientific field are converted into equations of the form f of x is equal to 0, and the main task is to find root of the equation. Now the question is what is meant by root? For the given equation f of x is equal to 0, a real number x naught is called root of the equation if it satisfies the equation f of x is equal to 0. That means, if we replace x by x naught in the given equation f of x, and if it equal to 0, then the value x naught is called root of the equation. Now if the function f of x is quadratic or cubic or biquadratic expression, then there is a rational formulas are available to find root of the equation. That means, if f of x is quadratic equation or cubic equation or biquadratic equation, then the roots of the equation can be expressed in terms of the coefficient of x. For example, suppose our equation is ax square plus bx plus c equal to 0, then its root is expressed in terms of the its coefficient. Now see here, a, b, c are the coefficients of the quadratic equation, ax square plus bx plus c equal to 0, then its root is expressed in the form minus b plus or minus square root of b square minus 4ac divided by twice a. That means, if our equation is in quadratic form or biquadratic or cubic, then its root is expressed in terms of its coefficient. But the problem arises when our equation f of x is a polynomial of higher degree. That means, f of x is of order phi u or greater than phi u, or it contains, or it is a transcendental equation. That means, it contains transcendental term, then there is no algebraic methods are available, or there is no any rational formula to find root of such a type of equation, and therefore numerical methods are required to find root of the equation, which is either algebraic equation or transcendental equation. Now what do you mean by algebraic equation? Now any equation of the form which a n raised to x raised to n plus a n minus 1 raised to n minus 1 and so up to a1 x plus a naught, in which a n minus 1 up to a naught are the coefficients, and these are the constant, and these are called coefficients of the equation f of x. Now such a type of equation is called algebraic equation. For example, x square minus 2x plus 1 or x raised to phi u minus 3x square plus 2x plus 10, these are the examples of algebraic equation. Now other equations, that means those equation contains trigonometric terms, for example sin x, cos x, tan x and so, then logarithmic term log x, or exponential term, that means the non-algebraic expression involving logarithmic term, exponential term, trigonometric terms, inverse trigonometric terms, etc. is called transcendental equation. Now for example, sin x plus e raised to x equal to 1. is an example of transcendental equation because it contains trigonometric term as well as exponential term. Now another example, x raised to 2.2 plus 1 is equal to 0. It is also an example of transcendental equation because the power of x is fractional number and therefore it is non-algebraic equation. Now similarly, log x plus x minus 10 is equal to 0, etc. These are the examples of transcendental equation. Now such a type of equation, that means either a polynomial having large degree or a transcendental equation has no rational formula which determines the root of the equation in terms of coefficients of the equation, is it? Therefore, numerical methods are required to compute solution, that means root of the equation f of x is equal to 0. Now in this video we discuss some numerical methods, namely the bisection method, the regular-Falsy method, the Newton-Raphson method, which are useful to compute the root of the equation f of x is equal to 0, where f of x is either algebraic equation or transcendental equation. That means this method provides numerical approximation to the root of the equation f of x is equal to 0. Now before discussing the numerical methods, we explain the basic or fundamental principle on which these numerical methods works. Now most of the numerical methods work on the following principles. Now assume that our function is continuous over the domain a to b. The main property is f of x is continuous function on the open interval a to b, and assume that the value of the function at point A as well as at point B are of opposite sign. This is the basic requirement for the root of the equation, is it? That means for a continuous function, if there exist two real numbers a and b for which f of a and f of b are opposite sign, that then there exists at least one point, one number in between a to b, say it is x naught, we satisfy the equation f of x naught is equal to 0, and that x naught is nothing but root of the equation. Is that clear? Okay. So in geometrically or graphically, if x naught is the root of the equation, means geometrically the curve of the function intersect to the x axis at point x naught, and that point of intersection is nothing but root of the equation. Now our main aim is to find this point of intersection numerically. For that we discuss some numerical methods. Now first we discuss the bisection method. This is the fundamental and most famous method in numerical analysis, which is used to find numerical approximation to the root of the equation f of x is equal to 0. Now how to work the bisection method? Now we discuss the algorithm or the fundamentals of bisection method. Now assume that f of x is equal to 0 be the real valued function whose root to be determined. Now this is given function. Now in first the main task in this method, choose any two real numbers. As discussed in previous principle, we have to choose any two real number a and b for which f of a and f of b are of opposite sign. That means f of a into f of b is negative. The value f of a into f of b, the product of f of a and f of b is negative. That means choose any two real number a and b for which f of a and f of b are opposite. Now for simplicity, let us see this graph. Now in this graph, the value of the function at a is positive and value of the function at b is negative. Is that clear? Okay. For simplicity, we assume that f of a is positive and f of b is negative. Now, once a and b are chosen, now define x naught, which is the mean of these 2 points. That means what? That means divide the interval a to b into 2 equally sub intervals. That means define x naught is equal to a plus b divided by 2, and therefore this method is called bisection method, because in this method we bisect the interval which contains the root. Is it? Now, once x naught is defined, now calculate the value of the function at x naught. Now, there are 3 possibilities. Suppose if value of the function at x naught is 0, what it implies? It implies x naught is the root of the equation. That means we have to stop our process. Is it? So, x naught is the root of the equation. Now, suppose value of x naught, value of the function at x naught is non-zero. Now, in our graph we have seen value of the function at x naught is negative. So, what it indicate? It indicate the root lies between a and b, because value of the function at a is positive and the new point x naught at which value of the function is negative. So, using basic principle of the root lies between these 2 points. That means the root lies between a and x naught. So, the next task is define x1. So, x1 is a plus x naught divided by 2. That means we again divide the new interval into 2 equally parts. So, x1 is the middle of that interval, now which is the second approximation to the root of the equation. Now, continue this process. That means again we check value of the function at x1 and determine whether it is positive or negative. Then root lies between either a to x1 or x1 to x0, depending on the sign of f of x1. Now, continue that process till we get the root of the desired accuracy. Now, remember that the bisection method always succeeds. That means if we use the bisection method, then it gives the guarantee of existence of root of the equation f of x is equal to 0, but the number of steps to calculate the root of the equation is depends on the choice of initial values a and b. If we choose the initial interval whose length is large, then the convergence to the root is slow, and if we choose the interval containing root whose length is very small, then convergence to the root is fast.